Hi, AB Calculus kids. It's 2004, question number 6. You'll notice I've already done a bunch of these set up because I didn't want you to have to waste time watching me. The idea is we need 12 slope fields, and for each of the 12 slope fields I got to plug in these ordered pairs, which I've listed over here. Plug it into this and graph the slopes. So first thing I'm going to do is I'm going to plug in all these ordered pairs here. Now, each of the x's here are -1 squared is simply 1. And now 0 minus 1, 1 minus 1, 2 minus 1, and 3 minus 1. Alright, so this first one is 1 times -1, which is -1, 1 times 0, which is 0, 1 times 1, which is 1, and 1 times 2, which is 2. So my slopes start off at -1, and then 0, and then 1, and then 2. Just make sure you're making it steeper as you graph it. Alright, moving to the next one. Here all the x's are 0. It doesn't matter what the y's are because 0 times anything is 0, 0, 0, and 0. So straight up the middle, 0, 0, 0, and 0. Alright, now we have to deal with this last set over here. So all the x's are 1s. Again, 1 squared is simply 1. And then I'm plugging in the y's. So my y's are, oops, 0, and then 1, and then 2, and then 3. And we get the same answer as before, -1, 0, 1, and 2. So, -1, 0, 1, and 2. Just trying to make them match as close as possible. It's not perfect, but you know, you get the idea. Okay, that's it. That's part A. It's a pain. Alright, part B now says, while the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points for which the slopes are positive. Now, folks, they just want to know where the slopes are positive. Now, first thing, the slopes are positive, and most people get part of this, but not all of it. Folks, if this is my slopes, what do we know about this? You square something, it's always going to be positive. I'm a little off there, but it's close. That's always going to be positive, so the question is that a positive times a positive makes your slope positive. So when will this be positive, or when will this be greater than 0? This will be greater than 0 if y is greater than 1. Now think about it. If y is greater than 1, pick a number bigger than 1 in here, and you'll always get a positive times a positive. So what happens almost every year, and if you did this on your own, is that people will say, slopes are positive when y is greater than 1. Now this question is only worth 1 point, and that's wrong. It's right with every little thing except one exception. The x's do matter. The slopes are not positive when the x's are 0. So slopes are positive when y is greater than 1 and x is not equal to 0. So easy to mess up on. I've messed up on it before. You just don't think about it. You get happy that, oh, positive times positive is positive. So you got to be careful. All right, part C. Okay, look at part C. It says find the particular solution. When they ask you to find the particular solution to a differential equation, another word for that is separate and integrate. So you separate x's on one, x's and dx's on one side, y's and dy's on the other side. Separate, then you integrate. You get the plus c. You plug in, you solve for c, you put the c back in, you get y by itself. Separate and integrate. If you have not tried part C yet, and you haven't tried separate and integrate, pause the video. Try separate and integrate. See how many points you can get. I'm pretty sure that this is going to be a huge part on your exam coming up. Okay? It's free response. They've taken out some topics that they normally would use, which means this topic they haven't taken out. It's probably on your test. And seeing it's only 45 minutes, it's probably worth a ton of points. So if I had to guess, separate and integrate could be almost worth a fourth of your points. Maybe not a fourth, maybe a fifth, but worth a lot. All right. So here we have dy dx equals x squared y minus 1. The dx multiplies to the other side, always does. And now this y minus 1 has to divide. This is a very, very easy question. But you got to be careful right here. If you don't separate, you don't get any of the points. And then you got to integrate correct. This one you should notice, bottom exponent's one bigger than the top. This is simply an ln. Alright, now remember an ln question is a du over u. Du over u is ln of u plus c. And if we did u substitution, which you should, you need to do u substitution. If the u is y minus 1, the du, its derivative is 1 dy. 1 dy is exactly what we have on the top. So it actually was perfectly du over u, which is why I just went directly into this. And the antiderivative of x squared is add 1 to the exponent, multiply by the reciprocal, plus c. And there you go. You just earned a ton of points. You put the plus c, take the antiderivative, is great. The next thing is they ask you to use f of 0 equals 3. We've earned 3 out of the 6 points. Now we got to plug this in, solve for c to earn 5 out of the 6 points. So y is 3 when the x is 0. And here we get ln of 2, oops, that's an absolute value, equals c. And here's a crucial part in the problem for finishing later on. This is c. It is important to note right now, did my absolute value have a job? No, it does not have a job. So I'm going to get rid of the absolute value, but I'm also going to note that the absolute value doesn't have a job. That means later on I can just get rid of this absolute value when I have to get y by itself. All right, this is what c is. I'm going to plug c back in, and there's an easy way to solve it to get all the points, but it's going to be a little ugly. We're just going to go for ugly in the points, and then I'll go back and show you the pretty way. So here I have ln of y minus 1 equals 1/3 x to the third plus c, but we now know c is ln of 2. Remember, all I want is the points. I've earned 5 out of 6 points. The only point left is can I get y by itself. First, e both sides. So it's e to the, and all of this is exponents. All of it is exponents. Okay? And now you'll notice I got rid of absolute values. Why can I just get rid of absolute values? Because earlier in the problem, for our initial condition, the absolute values were not necessary. They did not have a job. Therefore, in this part of our slope field, they don't have a job either. So we can get rid of them. And now I just need to add the 1 to the other side. And just like that, I'm done. All the points. Now it's a little bit ugly, but I need you to remember, your test no longer is multiple choice, since none of your tests is multiple choice. So you're no longer having to make things pretty at all. They say separate and integrate, done, give me my points, I'm going home now. Oh wait, I'm already home because of coronavirus taking the test. Anyways, what could I do here though to make this a little bit prettier? You could have separated these. Now the only reason you would separate this into e to the this times e to the this is those could cancel, leaving 2 as a multiplier. And now add the 1 to the other side. And that's what they did online. Well anyways, that's your third question we're doing today, and hopefully you learned a lot. Please keep working hard each and every day. You're going to destroy America because there's going to be a huge curve. And, you know, you're just smarter than they are. So keep working hard. Bye.